The learning objective of this chapter is to know the devices connected to ECDIS. The Ethernet LAN is a wired link between various devices connected to the ECDIS. It is important that the physical connections are secure and the connecting cable is not damaged. Some LAN cables are fiber optic and damage if bent. Devices communicate around the LAN at a baud rate that represents the data flow in pulses per second. If the baud rate is set incorrectly, the device cannot communicate, resulting in lost information. Standard 61162, developed by the International Electrotechnical Committee, applies to serial line communication. IMO require a basic minimum number of inputs to ECDIS. These consist of a navigation receiver, a gyro or electronic compass, and a speed and distance measuring device. There are other devices to assist navigation that could be connected to ECDIS. These consist of a radar, an anemometer, and an echo sounder. One of the most important devices feeding the ECDIS is the navigation signal, that could be from a Navstar GPS, GLONASS, Galileo, or E-LORAN receiver. The navigation signal allows position stability on the chart display and allows ECDIS to track the vessel in real time.
A system with integrity has an integrated navigation receiver, INS, feeding the ECDIS. Signals from more than one independent positioning system allow the integrated receiver to calculate a more accurate, most probable position, but also maintain position information if one system malfunctions.
If the primary navigation receiver fails, ECDIS will default to a secondary receiver, if available, and connected. The illustration shows an alarm on switchover. However, some ECDIS systems switch without alarming. If the primary navigation receiver fails, with no secondary navigation system available, the ECDIS will go into DR mode, using course and speed through the water to update the charted position. Point B in the illustration is the DR position, which can be misleading to an operator because the ECDIS is not aware of any effects of wind or tide. If it was aware, it would position the vessel more accurately at the estimated position, point C in the illustration. The operator should see the discrepancy by checking the vessel's position with other means. The satellite navigation signal feeding ECDIS has error, which is the sum of many errors in the system and receiver. An error budget summarizes these errors, but sometimes the errors add up to give a large figure. Sometimes they cancel each other out to give a small figure. A satellite receiver simplifies its indication of accuracy by showing an h-top figure. A value of 2 is a good fix. The higher the number, the less accurate the fix. An ECDIS may look for a secondary receiver if the h-top rises above a limiting figure set by the operator. A vessel is tied up on a berth with ECDIS positioning the vessel off the berth. This is precise but inaccurate, as the receiver consistently gives the same position with the same error. The second illustration shows precision and accuracy with the ECDIS repeatedly positioning the vessel on the berth correctly. There is a process on the ECDIS called position filtering that imposes a small time delay to the displayed position of the vessel. The delay, that could be up to 15 seconds, stops the displayed position jumping with errors in the navigation signal. The position filter can lead to apparent overshoots on a fast-turning vessel, as the illustration shows. It looks like the vessel overshot the corner, but in reality she did not. The filter acts a bit like a DR system, this time using course and speed over the ground, predicting ahead where the vessel will be, but then looks at the incoming navigation signals to work out where the vessel actually is. With the vessel turning, it is difficult for the ECDIS to predict ahead accurately. A short time later, the ECDIS catches up with the actual position of the vessel, indicating she is on track. Remember, the navigational receiver also has a filter, so the incoming signal to the ECDIS is possibly further time delayed. ECDIS is a very useful device to assist the vessel's navigation. However, there should be continuous checks on the displayed position using independent sources of position information. The illustration shows how a bridge team were misled with an ECDIS in DR mode. Grounding resulted west of the channel. When the radar overlay function is selected, ECDIS superimposes on the chart display everything from the connected radar screen, showing it in a green shade. When the navigation signal is accurate, radar overlay coincides exactly with the charted position of land and navigation buoys. The illustration shows radar returns from buoys coinciding with their charted positions, identifying the radar returns and that they are in their correct positions. The small radar return ahead to port, not on top of a charted symbol, is a good indication of a possibly small moving target. The radar returns from buoys can be seen, but one of them does not coincide with its charted position. This could indicate a buoy out of position or a small target and a buoy missing. ARPA radar will transfer the radar return from a ship target, but then also show an acquired target with circle and vector. When there is radar heading marker misalignment or gyro error present, the radar overlay will be skewed, as the illustration shows. The AIS signal of a target is seen as a blue triangle and classed as sleeping until the operator activates it via the AIS menu. The illustration shows an active target with vector indicating a course and speed over the ground. When a target is dangerous to the vessel, the triangle and vector are red and flash to alert the ECDIS operator. Class B and VTS AIS targets can sometimes be deselected from showing on the ECDIS display. Let's summarize what you have learnt in this chapter. There are many devices feeding the ECDIS via a LAN, and that the navigation signal is a critical input to ECDIS and must be correct. We've learnt that the level of accuracy varies on the navigation signal and that we need to keep an eye on the H-stop. The position signals are filtered, and that the radar overlay